Good morning, everybody. Welcome to another fun morning of chemistry with your host, me, Dr. White. Today, what we'll be doing is a couple things. First of all, I'm going to be going over how to use a scientific calculator, which is a good thing because you don't know how to use one, you're going to have trouble on my test, which I don't want to happen. Next, I'll go through chapter 2 problem set. And then I will go through the lab today you'll be doing, which is the density lab. What I mean by go through, I'll introduce it, introduce the concepts, and also I'll show you how to do the actual maneuvering in Beyond Lab Z, which will make your life easier, which I think is also a good thing. So we've got an exciting morning. And based on yesterday's lab, which I did, uh, we should be finished somewhere around 10:30ish, give or take a few minutes. And with that, let's get going. All right, one of the things you need to use in my class is a calculator. I have the Texas TI-30XIIS, which means it's solar. I've had this, I forgot how many years, and works fine. Uh, they're inexpensive. Unfortunately, I don't get kickbacks from Texas Instruments, for product placement, but you can get it at Staples, uh, Walmart, and as a friend of mine always calls it, that special French store he likes to go to, Target. And they're about 15, 16, $17, which is not expensive compared to when I was in grad school. The first calculator that came out was HP, and that was about $500 for a calculator like that did less than this. And back then, a good salary was only about $20,000. So that meant really it was like today a couple $1,000s. So let's get to it. What I would like to show you is how to do scientific notation, um, math on a calculator. Oh. And hopefully everybody can see the whiteboard. It's my board, a whiteboard. Or is it White's whiteboard? Never mind. All right. Say you multiply these two numbers. How do you do that? I could have used more complex numbers. You use your calculator. Oh, you get to see my desk. All right. This is a calculator. And first of all, I'm going to turn it on. And you may not see it, but you'll see right over here something and says focus SCI. Now, how do you get into scientific notation? You hit the second key, I call it the blue key, and see on top right here, let me do another pen. You'll see SCIENG. And if I hit it, you'll now see on the screen, I have FOL, which is floating point, SCI, scientific, and engineering I've never used. And by using this key, you can decide, and notice I have the lines under there. I'll now hit enter, and I'm now in scientific mode. Now, the first number was 2.0. By the way, don't get too dizzy. Let me do something here, give myself a little more room. All right, that's better. 2.0. And now we want to put times 10 to the third. How do you do that? Well, first of all, you have to go into the second key, blue key, and then right here above you see double E. That means scientific notation. I'll push that. You'll notice there's an E on the screen, and now I'll put in the number 3. So that means 2.0, E means times 10 to the third. I'm going to multiply it times 3.0, and now I want to do 10 to the fourth. How do I do that? I, blue key, second key, double E, and I'll hit my 4, and notice it's 3.0 times 10 to the fourth. That E means times 10 to the power after the 4, after the E, which is 4. I'll hit enter, and now you'll see right here, I have 6, and then very tiny letters. I don't know if you can make it out, X, 10, and then 0, 7. So that'd be 6 times 10 to the 7th. Actually, this problem would be 6.0, but zeros after a decimal, when there's nothing else, your calculator, at least mine, doesn't show. Now, let's do that again, but now let's do something else. First of all, always make sure you clear it. Let's try another one. And now I'm going to multiply 3.0, but notice I have 10 to the minus 4 times 5.0 times 10 to the minus 6. So the question is, how do we do that and get the correct answer? Well, you use your calculator and pay attention, because I want to show you a mistake students make when doing this. My messy underneath. Oh no, you're seeing the secrets of Dr. White. All right, first number was 3.0, which I just did. And then I want to do times 10 to the minus 4th. So I'll do my blue key, double E, but now I want minus 4. Please pay attention. Come on, focus. That's better. All right, now focus. Use this key for minus, not this for exponential minus. Again, use this key for minus with the bracket minus close bracket, not the key used for subtraction. Students use this one and get the wrong answer. I'll say that again. Use this one, not this one. So I'll do minus 4. If you look up here, you'll see after the E, my hand stops shaking, E minus 4. And then I'm going to multiply it times, what was it, 5.0. And again, now I want to do minus 6. So I'll do blue key, double E, and I'll use this key. Notice Dr. White will never be a hand model on TV. And I'll do my minus key right here, not this one, and I'll put 6 in. And if you notice, I have 5.0 times time to the minus 6. I'll hit enter. And if you look at what I have 1.2 times 10 to the minus 9. Don't forget that minus sign when you're doing calculations. And that's how you use your calculator. For division, you do the same thing. Now, listen carefully. I would highly recommend that you practice doing some of the math from problem set 2, or just do some of your own problems like I made up some, and practice with your calculator. Practice it. Let me turn mine off. These are really good. I think I've had this at least 8 or 9 years. And I would take it to class and lab. I'd take it when we had face-to-face teaching. For tests, I'd bring that, and I have a couple extra ones to give the students. But you should get your own. And practice. If you have problems after lab, like today or next week, I'll stick around and help you. Also come to my office hours on Monday, Wednesday night. There's yet to be a calculator that's been made in the last 10 years that I haven't figured out how to use. Now, if you have the fancy graphing calculators, that's okay. That has the same functionality. The key location will be a little different than on my calculator, but it still will be about the same type of operations. Now, how do I figure out other people's calculators? I look at the instruction manual. Dr. White does something a lot of people don't do, read the instruction manual. And even sometimes then it's a little difficult. I see a question. Did I say 1.5? I think it was 1.5. I forgot, whatever. But yes, it would be, I think 1.5 times 10 to the minus 9. Thank you, Danny. And by the way, if I make a mistake, correct me. Last time I checked, I don't walk on water unless it's frozen. And even then, I try and stay off it. Hold on, where did I just do something? All right. That's the calculator. And now let's go in a second to the problem set. Now, one of the things I should tell you is I have bad hearing. I have about a 60% loss. My sisters have about 80%. I can hear without my hearing aids, like I don't have them in now, because I have big speakers that are amplified. But one of the hardest things for me to make out are letters of the alphabet. And we're going to do one page at a time in the problem set. We'll do that the whole semester. And if you say something like, can you do 5D, like in dog, I might not pick it up and I might ask you to repeat it once or twice. And that's my problem, not yours, but please work with me. All right, let's do the problem set. Remember, these are located in Blackboard in which I'm going to show you problem set answers. I should warn you, there's a couple mistakes we found yesterday. Dr. White makes mistakes sometimes. Let's get back to the top. All right, does everybody see Dr. White's chapter 2 practice problems on the screen? Thumbs up, people, thank you, or V for victory. And also, have you noticed there's no clicking? I finally solved that, like I said, thank goodness. All right, let's take a look at this. Write the following numbers in scientific notation. How do you do that? You look at a number, and if there is no decimal, you look where if there should have been a decimal, and you move it to the right of the first non-zero integer. And if the number is greater than 10, 10 to the x power is positive number x. If it's less than 1, 10 to the x, x is a negative number. So if we look at A, If there was a decimal point to be here, I move it 1, 2, 3, 4, 5. We are now at 5 moves. And if the number is greater than 10 and there's no decimal point, any zeros at the end, you drop. So this would be 6.52. Then I moved it 5 times 10 to the 5th. Now, if the number is less than 1, like in D, you do the same thing. You move the decimal point, and this is 0.00567, to the right of the first non-zero integer, 1, 2, 3. Now here, if there are any zeros at the end, you keep them. In this case, we don't have it, and therefore this would be 5.67. I moved it 3 times, but the number is less than 1, so x and 10 to the x is minus 3. And if we look at B, again, this is number greater than 10. If there was a decimal point, I'd move it to the right of the first non-zero integer, 1, 2, 3. So it'd be 1.23 times 10. How many times did I move it? 1, 2, 3. 10 to the x, x is 3. Now here in E, when x is, and I see a question, hold on. Okay, whoever. And in E, I have to move it to the right of the first non-zero integer, the decimal point. Notice this is less than 1, so I move it 1, 2, 3, 4, 5, 6, 7. So I get 8.674 times 10 to the x. X, because this number is less than 1, is negative, minus, and I moved it 7 times. This is how I write my 7. I think I mentioned in high school I had a German teacher from Germany, Herr Brink. God, I still remember him. He was a great teacher. And that's how he wrote his 7s, which is how they write it in Germany and parts of Europe. And I thought that was the coolest thing in the world. And I've been doing that forever since. Do I have time? Yes, I do. Time for a Dr. White story. Back when I was in high school, I had Herr Brink, and a new movie just came out. And he came Monday. We had German class, and he said, "Guten Morgen, good morning." And he would talk some German, it was German class. And he said, "I saw a great movie." And we asked, "What, Herr Brink?" Herr means Mr. in German. And I saw the Fledermausmann. We're all thinking, what? Batman. And he saw the first Batman movie. This is before you were born. Oh, I shouldn't have said that. And Fledermausmann is German for Batman. Fledermaus is bat. All right. It's time for Dr. White to share the fun. Why don't you write the following number in scientific notation? I get to see everybody's pretty faces out there. You get to see my face. I don't know. Is it pretty? Well, the beard looks nice. All right, I see somebody's beat me to the punch. Let's do it. All right, if there were a decimal, there's not. I'm going to move it to the right of the first non-zero integer, and that's 1, 2, 3, 4, 5. I moved it 5 times, and this number is greater than 10, and therefore zeros at the end I'll drop. So I have 4.67. I moved it how many times? 5, and that would be the number. Oh, let's try another one. That's 2030000. Quick commercial from Dr. White. Make sure by later today you turn in the safety lab that's due today, so you get your 10 points. Don't forget, if you don't hand in a lab, you get 0 points. And labs, the way I grade, are easy points. Labs should be fun, and I'm not looking when I grade a lab to say, oh, how many points can I take off? That's not how I grade. All right, let's do it. And this number is greater than 10. If there was a decimal, it would be right here. 1, 2, 3, 4, 5, 6. I moved this 6. Hopefully I counted right. 1, 2, 3, 4, 5, 6. I did. All zeros at the end, because this is greater than 10, you drop. And then this would be, and I'll get to who's ever, 2.03 times 10 to the 6th. 1, 2, 3, 4, 5, 6. And let me look. All right, and everybody seems to have put it on. All right, let's do some more. Now, these were numbers that were greater than 10. Why don't you do this one? Write the following in scientific notation. Go. By the way, I'm going to be real mean this morning. I'm going to work your brain. And when you're done, give me a thumbs up or smile or do both. And I try and give everybody time to finish, so be patient. If you finished early. I think everybody's done. Let's take a look. How do we do this? All right, now, this number is less than 1, but we still move the decimal point 1, 2, 3 times to the right of the first non-zero integer, and that would be 5.14. Now, since this number is less than 1, x, 10 to the x is a minus number, minus 3. And that's how, oh, let's do another one. And why don't you try this one? What would be how would you write that in scientific notation? And if I were to put it on a test, 2 points each. Ooh, I gave away a test question. Bad, Dr. White. And don't forget, if you haven't done it already, most of you have, don't forget to upload the signature sheet filled out to Blackboard in the assignment area. All right, it looks like everybody's done. Let's do this. First of all, this number is less than 1. We're going to move the decimal point to the right of the first non-zero number. 1, 2, 3, 4, 5. We moved it 5 times. Now in a test, you don't have to show any of this, but I'm showing you the mindset. Now, that'd be 7.1, but if the number is less than 1, any zeros past the decimal, you keep. So this would be 7.10 times 10, and x is minus 10 to the x minus, and it's 5. So that's how you do it. Let's do one more. And here, write the following in scientific notation. And if any of you like to turn on your webcams so I can see your pretty faces, it makes me feel better. But I think next week I'm going to be trying an experiment with you. Yes, Dr. White experiments with his students. And what we'll be doing is I'm going to work on finding a way. I think I have a way for me to know you a little better and for you to meet some of your classmates. All right, let's do it. I think everybody's done. Notice this number is less than 1. So you move the decimal point to the right of the first non-zero number. And any numbers afterward you keep, including zeros. So this would be, I moved it 2 times, 1, 2, 3.010 times 10 to the x, when this number is less than 1, is negative, and I moved it 2 times. And that's how you do that. Let's move on. Now, problem 2, I should have removed that. I didn't have time this semester. We really don't do that. Since you're using a calculator, never on a test will I ask you write it in decimal. But if you did it, it was good practice. But this will never be on a test, and I'll never ask you to do it on a test. Or in real life, it really doesn't happen. So, oops, I should have taken it out. Now, an important part of science, especially chemistry, is significant figures. And that's a measure of how accurate a measurement is. The more significant figures, the more accurate the measurement. But when you do multiplication, division, addition, and subtraction, you have to consider significant figures. Well, the first thing you have to do is know how to determine how many significant figures are in a number. And I'll never ask you what the rules are, but I'll expect you to know how to use it, because on test 1, test 2, 3, 4, and the final exam, it will say underneath your name, please use proper significant figures for all calculated answers. And if you don't do that, I take off a point. Like if it was a 5-point problem and you did it right, but you have the wrong significant figures, you get 4 points. If you do enough of those, you're going to lose a lot of points. So let's go through this. All right, 1, all non-zero numbers, integers, are significant. Zeros at the end without a decimal point are not significant. Lead zeros with a decimal point are not significant. Zeros at the end with a decimal point are significant, and zeros confined in between non-zero numbers are significant. So if we look at A, well, they're all non-zero. So there's 1, 2, 3, 4, 5 significant figures. If we look at B, oh, zero at the end, but no decimal. So that's not significant. All non-zero numbers are 1, 2, 3, 3. If we look at C, we have, oh, a zero, but it's in between two non-zero numbers. So all these are significant, 1, 2, 3. When you do scientific notation, you ignore 10 to the minus or plus whatever. The only number in front of the times or X is what you consider. So 3.768 are all integers. There are four of them, four significant figures. If we look at E, we have, lead zeros, but lead zeros in the front of a number, generally it's a number less than 1, are never significant, and therefore non-zero number, non-zero, non-zero, 3. And finally, zeros at the end with a decimal are always significant. So here's a non-zero number, 1, another one, 2, and these three zeros are, so it's 3, 4, 5, and that's how you get 5 significant figures. All right, time for you to have some fun. How many significant figures are in the following number? I'll give you 2.8 seconds. I'll give you 4. 3, 3.2, 3.7. Time's up. All non-zero numbers are significant. 1, 2, 3, 4, 5. And the answer is 5 significant figures. Let's do another one. How many significant figures are in this number? All right, I think everybody's done. Let's take a look. And the answer is, all non-zero numbers are significant. Zeros at the end are not, but a zero that's confined between two non-zero numbers are. So this would have 3. Oh, this is fun. We got to do some more. How many significant figures are in this one? Time's up. Well, here's a decimal point. Zeros at the front of a number are not, but non-zero numbers are, so the answer would be 2 significant figures. Let's do one more. All right, how many significant figures are in that number? And by the way, let me make the decimal point nicer. Aren't you glad Dr. White mastered the writing tablet? It's just like I would be doing in a classroom. All right, let's take a look at this. Now, this is sort of a gray area, but it's still, I try and stay away from gray areas on tests. I usually do, but still, let's take a look at this. Non-zero numbers are significant right here. Zeros that are confined are significant, plus zeros after a decimal or where there's a decimal at the end is significant. So all these are 1, 2, 3, 4, 5. And this would be what I call a gray area that I probably would never have you do a calculation where you'd end up with something like this. This would be more realistic. And there you could say this is confined, or and that would be one way of considering it. All right. Now, once you know how to do significant figures, when you do calculations, which I will go through this morning, you have to round off, because when you do math operations, you have to consider significant figures. Now, I'll say this again, but when you do math, if you do multiplication division, your answer should have the same number of significant figures as the number that has the fewest significant figures. And I see a question. Danny, thank you for your question. Danny just asked a question. If there's zeros after a decimal point, are they always significant? The answer is yes. If there's zeros at the end of a number where there's a decimal point or past the decimal, are they, well, I think I said that there, always significant. If there's zeros in the front of the number, a number less than one, those are never significant. Let me say that again. Zeros after a decimal at the end are always significant. Zeros at the front of a number are never significant. And thank you for your question. And as you know, all questions are good questions in my class. All right, so you have to round off. How do you round off? You find out how many significant figures, and the next one after the number you have to keep, you look at that. If it's 4 or less and the number is 10 or higher, you drop that and replace it with a 0. If it's 5 or higher, you replace that with a 0, and then the number in front, the last significant figure you keep, you increase by 1. If the number is less than 1, or past the decimal, I should say, you should either drop it if it's, and anything past it, if it's 4 or less. If it's 5 or higher, you drop it, and anything past it, and then the number in front you increase. What the heck did it just say? Well, let's go through it so you understand this. Now, because Dr. White, when I was in college, high school, college, and grad school, we used slide rules because they didn't have calculators until I got into grad school, and even then I didn't use one. They're way too expensive. And slide rules, I'll have to bring mine to class on Monday. You can only get 3 significant figures, so a lot of times Dr. White will be in his 3 sig figures run. All right, A, round this off to 3 significant figures. Keep the 1, keep the 1, keep the 5. The 1 to round off is 5, that's 5 or higher, you drop that. The number in front you increase by 1. Here, round it off to 3. Keep the 1, keep the 2. This 0 is significant, it's confined. And then the number to round off is 6. You drop that because it's past the decimal, and the number in front you increase by 1. Now, when the number is greater than 10, like this one, if I want to round this off to 3 significant figures, keep the 1, keep the 3, keep the 3. The number to round off, and by the way, the convention I usually use, round off number on my problems, I'll put the double squiggly or 1 squiggly line. This is a squiggly line. I guess I named it after Squidward. Bad joke. And if you don't know SpongeBob, that just went over your head. But anyways, keep the 8 is to round off. It's 5 or higher. I'm going to replace that with a 0, and the number in front I will increase by 1. Now, this is something students get confused. Think of this number. It's 133,800. Now, what's the number above the 3 significant figures? 134,000. What's below? 133,000. And students somehow like to round this off to 133. which is not in between those two numbers. And that's what rounding off does. You go up or down in the range of the number. And if we look at a number less than 1, F, round this off to 3 significant figures, keep the 5, keep the 8, keep the 7, that's my 3. I use the 3 significant figures. I use the number 3 to round off because that's number 4 significant figure. It's 4 or less, I'm going to drop that to 0, and I get 0.587. Your turn. By the way, SF is my abbreviation for significant figures. I'll never use that on a test, but on the whiteboard I will because I'm lazy. And let's do the following. Round that off to 3 significant figures. And it looks like everybody's done, so I better get to work. All right, if we round it off, keep the first one, keep the second one. This is the third because we want 3 significant figures. This is the one we use to round off. Is that 4 or less or 5 or higher? 5 or higher. I'm going to drop that, increase this by 1, and the correct answer is this. And round this number off to 4 significant figures. Ooh, Dr. White got out of his rut of 3 significant figures. Ooh, coming attraction. The density lab is a lot of fun. All right, looks like everybody's done. Let's do it. Notice there's a decimal point here. Keep the 5, that's my first significant. The 0 is significant, 2, 3, 4. So I want to do 4 significant figures. This is the number to round off. Is that 4 or less or 5 or higher? It's 4 or less. So I'm going to drop that because I'm past the decimal, and I'm going to drop that, and the correct answer to 4 significant figures is that. And let's do one more because practice is good for your grade. Round this off. Oh, let's go back to my favorite 3 significant figures. And this is something you'll be doing on the test. All right, looks like everybody's done. We want 3 significant figures. Keep this one, keep this one, keep this one. That's 1, 2, 3. This is the number to round off. Is that 4 or less or 5 or higher? 5, so it's 5. Since we're past the decimal point, I'm going to drop this, this, this. This was 5 or higher. I'm going to increase this by 1. So the correct answer is 12.7. And that's how you do rounding off. One thing I haven't mentioned is, I haven't done this in a long time. Don't forget, in my class, there's no such thing as a dumb question. Always feel free to ask questions. All right, let's continue on. And the answer, Kelly, is of course. I've got you until midnight. No, I'm just kidding. Oh, I scared some people there. Heads shifted. What did you say? I don't need this up there anymore. Dr. White likes to play with your minds if you haven't guessed that already. All right, let's do one more. Why don't you round this number off to 4 significant figures? And it looks like everybody's done, so I can get to work. All right, we want 4 significant figures. Keep the 1, keep the 9, keep the 8. Here's my decimal. So this 0 is significant. That's my 4th. This is the number, the 1 after the last significant figure is your round off number. Is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. Since it's past the decimal point, I'm going to drop this and everything afterward, increase the number in front of it by 1 unit, which would that, and that would be your answer. 198.1. As I look at that, 1981, hey, that was a decent year for me. Uh-oh, I just did a generation gap. All right. No questions. Let's move on. Now, next one was, what's the correct answer for? And when this semester, you'll be doing a number of calculations where you'll be using both scientific notation and regular numbers. Now, quick thing, common question I ask is, say on your calculator, do you use scientific notation or normal? Well, if it's scientific numbers you're using, scientific notation, then you use scientific notation. If it was 5.7 times 6.832, you can use either one. Dr. White knows how to interpret scientific notation. So feel free on a test to do either one, unless it's a large or very tiny number with a lot of zeros, then please use scientific notation, but your calculator will do that too. Now, if I look at the clock, let's take a break, come back, and give you a whole extra minute. Remember, I'm gonna get you out early today by midnight, actually before quite early. Come back at 9:55. Take a 5-minute break. I'll see you in 5. I'm gonna get up and stretch. Uh-oh, I'm running a minute late. I'm sorry. Oh, I'm so sorry, bad doctor. All right, let's get started again. Ring, 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 ring. If you ever saw the old movies where you had the one room schoolhouse in the Old West and the school marm, otherwise known as the teacher, would go out with a big bell to get all the students in. And I just stopped that. All right, let's continue with chapter 2, problem set. And the question is, how do you do math operations to get the correct number of significant figures? And the rule is for multiplication and division, you get the same number of significant figures in your answer that the number that has the smallest significant figures that you multiply or divide. Let me say it again. Your answer has the same number of significant figures as the number you multiply or divide that has the smallest significant figures. That sounds better. So let's look at A. If we look at A, you'll see 5.5 times 6.351. Well, first of all, you have to figure out how many significant figures. This has 2, this has 4. Which is the lower number? 2. Now, your calculator will give you a number like this, which is a lot of significant figures. So you have to round this off to 2 significant figures. And this is how we do it. Keep the 3, keep the 4. 9 is to round off. You drop past the decimal, increase this, and this would be the correct answer. If on the test you put 34.9305 and it was a 5-point question, I take 1 point off because of wrong significant figures. And that's how you do it. If we look at number B, notice I have 5 significant figures, 3 here on the second number. How many significant figures should your answer have? And same as the lowest number of significant figures as the number you multiply or divide, 3. So you round this off to 3, keep the 9, keep the 8, keep the 6. The round off number is 1. It's past the decimal. Therefore, I'm going to drop everything, and you get 98.6. Now, I made a mistake in D here. The mistake is that should be 5, not 4 significant figures. And therefore, the answer is still correct, but I made a mistake. Again, when you multiply and divide, your answer should have the same number of significant figures as the number you're multiplying and dividing that has the smallest significant figures. Now, E, I made a mistake. Oh, I'm going home. I made too many mistakes. I am home. But anyways, this should be 5 significant figures. And the answer here should be not this one, should be 6.2713, because that's my 5. And the 2 is to round off and drop. So this should really be 6.2713. And that should be 5 significant figures. Oh, I'm so crushed. And when you divide, you do the same thing, 1.22 divided by 5.232. It's division. You get 2 significant figures, and this is round off 2 significant figures. Now, important thing, when you're multiplying or divided, let's do H first. You don't use 10 to the whatever power to determine significant figures. Only the number in front is used as significant figures. Now, let's go back to G. If you did this on your calculator, you might see something like 2.3238, and I didn't put it down here, times 10 to the 0. Whenever you see 10 to the 0, that's really the number 1. So anything times 10 to the 0 is that number. I'll say that again. Whenever you see 10 to the 0, I'll get that question in a second, or I'll get to it. All right. Cully had a good question. Thank you for your question. Now, your calculator uses E. That's just your shorthand. On the test, when you write your answer, I would do the X. But if you do the E, don't tell anybody, but I won't take any points off. I'll just smile. Oh, look what they did.
I have a question.
Go for it.
I meant problem E. I was confused where it said 10 to the 6th power.
Right, that's what I just said.
Oh, sorry.
First of all, you never have to say sorry in my class unless you throw something at me. Well, you can. I'm on the other side of your monitor. But in other words, don't say you're sorry. You don't have to for asking questions. And if I interpret it wrong, let's take a look at something. This would be 1.23 times 10. My X's are not good this morning. I'm having a bad X day. But anyways, 1.23 times 10 to the 6th. And this is how I'm always going to write it on a piece of paper. However, your calculator, for whatever reason, I don't know why, I've never been involved in manufacturing calculators, would write it on your screen, or if you're inputting it like this, okay? And in a spreadsheet, you do the same thing. So this is your calculator. This is on paper. If you do this on paper, I'll take a second, what? And then oh yeah, it's an E, that means this, okay? Does that help?
How do we get the 6? I guess that's what I'm saying.
All right, in terms of calculator or paper?
If we were to do it manually, do we just do it by calculator? Like forget it manually, just do it by calculator?
That's a good question. The answer is yes. All right.
Okay.
For my class, unless you're adding a number like 2 plus 5, which I think a couple of times you will do stuff like that, you'll be using a calculator. Your calculator can either be in scientific notation or flow. If you have a large number with scientific notation, obviously put it in scientific notation. Otherwise, you're going to see a bunch of zeros at the end, which will usually you'll make a mistake writing that down. So for anything that you have to do a math, a multiplication or division, use your calculator. Does that help? And thank you for your question. Like I said, all questions are good questions and are always encouraged. And that's what I was showing right here. If you ever see, and I'll do it on my blackboard, whiteboard, but first. All right, I'm glad I explained it better. By the way, did I do a good deed? I think so. I hope he's listening up there, not to bring religion into the classroom. And that's how you do it. All right, let's look at addition. Now, addition is a little different. And it took me a while when I was a student to be able to understand what's going on. And that's why I'm going to go through it. I can't think of any time ever on a test that you'll do subtraction and you'll have to deal with significant figures. The only subtraction I can think of we do is in going from degrees F to degrees C, and that 32 is an exact number. All right, now for addition, you get the same number of significant figures past the decimal in your answer as the number that has the fewest significant figures. Anything to the left of the decimal, you just add and you keep as is. So if we look here at B, we add these two together. This is the number our calculator would give us. But notice the first number, you have past the decimal 336. Anything past the decimal is always going to be significant. That's three significant figures. For B, you have 0.58. That's two significant figures. Therefore, which is a smaller number? 2. Therefore, past the decimal, you need two significant figures. Here's my decimal point. Therefore, I have a 9. That's my first significant figure past or to the right of the decimal. And 1 is the second one. I use the 6 to round off. That's 5 or higher. I'll drop it because we're past the decimal. And the number in front of it, 1, I'll increase by 1. Anything to the left, you keep the same. And that's how you do it. And same thing for C. You add it up. This is what your calculator gives you. And next, how many significant figures to the right of the decimal does the first number have? 3777, 4. How many does 3.3 have? 1, which is a smaller number, 1. So I round past the decimal, this to one significant figure. Keep the 6. I'll get to the whichever question in a second. Use the 7 to round off. You're past the decimal. You drop these 7s. You increase this 1 by 1, and this is the correct number. Now, someone asked, are you always going to use the lowest significant figure to round off? It matters what math operation you are, and the answer is yes. If it's multiplication and division, it's the whole number, the lowest significant figure. If it's addition, it's to the right of the decimal point. So, Erica, does that answer your question? If not, ask some more. Excellent. Look out, I'm on a winning streak now. I'm answering questions correctly. I usually always do, like always. All right, let's have you try one or two. Why don't you try adding this, and what would be the answer using proper significant figures? Well, this one might be a little harder than I thought, but let's see if you're up to the challenge. Well, good news, I'm looking out at the crowd and I don't see anybody with smoke coming out of their ears. And for those of you who don't have your camera, when you're done, give me a thumbs up. You can do that by the little emoji thing at the bottom of your screen or wherever you have the controls. All right, looks like everybody's done. Let's do this. All right, if I put this in my calculator, this will be the number I get. But now we have to look at, here's my decimal point. How many numbers to the right of the decimal point? First one, 1, 2, 3, 4. Second one, 1, 2. Remember, zeros past the decimal point are significant. So this would be 2, which is the lower number. Hopefully you pick 2. So here's my decimal point to the right of the decimal. Keep this, use this to round off. It's 4 or less. I drop that, and the correct answer is this. Oh, let's do one more. And why don't you add this one up? And remember, as it will say on my test, please use proper significant figures for all calculated answers. And when you're done, look up and smile or give me the thumbs up. And by the way, I didn't mention it earlier, but thank you all for coming today to my class. And aren't you glad this is virtual and you don't have to go out in the cold and the snow? I am. All right, let's do it. It looks like everybody's done. If I added this up in my calculator, my calculator just had a short circuit. Let's see, did I do this right? And the answer is yes. Now, if you put this down on an answer, I'm going to take off a point because it's not proper significant figures. Here's my decimal point. How many significant figures in the first number to the right of the decimal? And the answer is 4. The second number, how many? 2. Which is a smaller number? Times up, it's 2. So how do I round this off to 2 past the decimal? Keep the 0, keep the 7. Use this to round off. Is that 5 or higher? And the answer is yes, it's 5. So I'm going to drop this and increase this by 1. So it's 1002.08. And that's how you do significant figures. Significant figures are important a part of any time in science or business too. You use any kind of multiplication or division or addition or subtraction. We're not going to really do subtraction, and that's how you do it. Any questions? Looking down at my chat box to see if anything comes up. All right. Guess what time it is? It's time for lab. Let's do our lab now. Now, if we were at COD in the actual lab, I'd be doing just like I did this morning. We go through on a lab days problem set, and then I'd do my what I call introduction, teach you what you're going to be doing in the lab. Then I'd let you work in the lab, and I'd walk around, make sure you're doing it safely. Now, what we'll be doing this semester is well, it's like I'm going to do now. I'm going to do my introduction, and then you'll do the Lab Z, and I'll show you how to do it in Lab Z, beyond Lab Z, and then I will let you go, and you can do it on your own in the actual lab, and you can do it today or tomorrow. Just make sure you do it enough. Do it so you get it done by next Friday to hand in. Now, each lab that we do in Beyond Lab Z, I will have in the, or every lab, first of all, will be in the assignment area of Blackboard. And I'll have what you need to use or look at as downloads. Now, today's density lab, I have in there both the Beyond Lab Z PDF. That's a sort of a reference. This semester, I will write all the labs myself that you'll actually, what you'll do and what you have to either put in data from when you do the lab and answer questions. The PDF files from Beyond Lab Z is this reference. You do not have to do any of the questions in there. You don't do the work outlined in there. Everybody clear on that? And I sent out an email yesterday because someone had a question after class had left about that same thing. I thought I'd clarify it. All right, let's get to the lab. Today's lab deals with an important physical characteristic. Ooh, you know about that, physical properties, called density. And density is something you measure for both liquids and solids. And you can have the density of water, you can have density of gasoline, you can have the density if I had steel, if I had a diamond. Nope, I don't have my diamonds on. I don't think I own a diamond. I have rubies, but no diamonds. Anyways, uh, and it's an important physical characteristic. All right, thumbs up, people. Do you see Density Lab on your screen? Thank you. All right, this is a download from the assignment area. And when you're done, you should upload the lab as a single PDF file to the assignment area. Now, quick thing. If you don't have a printer, or if your printer died last fall, it took me a while. Let's see, right there, you see my new printer that I got about 2 weeks ago. It's a good one. It's quite inexpensive. That only cost me $200. It's a nice HP printer scanner fax. I don't fax anymore. I don't know who does. You just make a PDF and email it. But anyways, oh, by the way, I learned a number of years ago, PDF files emailed are legal in all courts, both state and federal. I learned that when I was working, sending back and forth signed non-disclosure agreements. But anyways, if you don't have a printer, what you should do on a piece of paper is the data you're supposed to put down, write that down, make sure in the upper corner, you put your name, and also on the top what lab it is, even though it should be obvious to me, but still makes my life easier, which is a good thing. And then for the questions, you don't have to write out the whole lab. You don't have to write out the questions. Like in the lab we're doing now, question 1, you put in your answer. And then you'll either, if you have a scanner, make it as a PDF file, or if you don't have a scanner, I have on Blackboard a part where it has information how to use your cell phone to take pictures and then make a PDF file. And both winter and fall semester, I had a number of students doing that, and nobody had trouble doing that. If you do, come to my office hours and I'll help you. Okay. All right. Now, density is defined as weight per unit volume. One other thing I should mention, anything we do in the lab, I will never ask on a test question or final, because anything on my test or final, I'll talk about in the lecture. And I'll also, I guess, in the lab and the practice problems, but never in an actual lab we're doing. All right, so density in Formula 1 is weight per unit volume or weight per volume. So if you measure the weight of something and you measure the volume of it, divide the weight by the volume, that's the density. And that's how you measure density. Now, an important aspect of density is lower density substances float in higher density liquids, and higher density substances sink in lower density liquids. Again, I'll mention this, things that are lower density sink in higher density, things that are higher density sink in lower density liquids. How many of you have ever seen the oil vinaigrette dressing you can buy in the bottles, where Dr. White makes his own? And after you've used it, you shake it up, put it on your salad, and then you put it down. What happens? It separates into 2 layers. There's a top and bottom. And the top is the vegetable oil, an oil vinaigrette. The bottom is the vinegar, which is mainly water. Why? because vegetable oil has a lower density than water and it floats on top. Now, if you happen to have one at home, if you happen to have a cannonball, they're made of iron, they're quite heavy. Or if you have some weights, if you work out, pump iron, Dr. White does. And if you have a big barrel of water or a bucket, if you took the cannonball or weight and let it go, will it float on the water? No, it goes right to the bottom. Why? Because iron has a higher density than water. Just in case you don't know, water has a density of 1.00 grams per milliliter. And it tastes good too. Now, if you want to see how to do if you were in a lab, you don't have to look at this. A liquid determining the volume, look at this YouTube. If you want to learn how to do a solid, look at the YouTube here. Now, when you do a liquid, now I'm going to show you how to do this in lab, beyond Lab Z, in about 2 or 3 minutes. What you do is you use a graduated cylinder. And a graduated cylinder is a more accurate way of measuring liquids, similar to the measuring cup you have in your kitchen. And for solid, we do water displacement, and I'll show you how that's done in a little while. Now, today's lab, there are 3 parts. This will all be done in Beyond Lab Z. Take a look at the PDF file. This is a reference. You really don't have to read it, but if you like to, remember, in all the Beyond Lab Z PDF files, you will not do those experiments. You will not answer those questions. You'll answer it in my lab. All right, so in part 1, you're going to be working with some liquids. And for each liquid, you'll do the following. Now, I'm going to go through this real quick. You'll open the density lab, and then I'm going to show you that in a minute. Turn the balance on if it's off. Place the empty beaker on the balance and push the tare button. Tare is the chemist's way of saying 0 balance. Then turns out you don't even have to put it back on the bench. I was wrong here, but you can. Then pick a liquid from the dispenser in the upper left, and I'll show you this in a second, using the up and down arrows, and then dispense the full amount. Turns out what they call full amount is not truly full amount. I got faked out when I first started playing with the labs a while ago. And then you'll record the volume, and I'm going to show you how to do that in a minute. Put it in table 1. Then, oh, by the way, when you poured, here am I. Pour the contents of the graduated cylinder into the beaker and place the beaker on the balance. You can actually leave it on there. I found that out too. Record the weight. Pour the contents back into the graduated cylinder, put it back. Use the blue handle to empty the graduated cylinder. Then you'll repeat steps 3 through 9 for each liquid in table 9. Table 1. Yeah. And you'll calculate the density for all the items in table 1 using this formula. Weight of the liquid divided by volume. Use proper significant figures, hint. And here are the ones you'll use. Now, when we do this in a lab, we have unknowns for you to do because it makes it interesting. The unknowns in Lab Z, they call virtual fluid A, or virtual, there are a couple of them. Now, if your last name begins with A through L, you only have to do A. If your last name begins with M through Z, do D. If you want to do both, that's okay, but you only have to do one. All right, let's go to Beyond Lab Z. I'm going to log in. Now, when you log in, thumbs up, people. Can you see installation and setup on your screen? Thank you. It took, first time I came back after I installed it, what am I doing in installation and setup? Well, you click connect. And here I am, and I see a question. Use your school email address for Beyond Lab Z. I think I sent out an email or said that, but please do that. If you didn't, that's okay, but please do that. Actually, I'm not grading it, so you really could use anyone. If you notice, I installed everything. Today's lab, can everybody see physical science? Yep. What you'll do for the high school, you'll click on open. All right. Can everybody see at the top mechanics, density, etc.? Sometimes, hold on. Nope, you can't. Now could you see it? Okay. Click on density. If you're having problems, oh, it makes funny noises. There's a way if you, I forgot how I was told how to shut off the noises if you don't want them. But anyways, everybody see the lab with the graduated red cylinders here? Good. All right, couple things. Over here is your liquids. And make sure this is full. You can do half, but do full. And the arrow up and down allows you to pick different materials, liquids. Now, oh, let's do water. Now, first of all, I'm going to put my beaker, first of all, check, it's already at 0 chair. In real life, people walking by in air currents are going to cause the balance to change a little. If it's not exactly 0, that's okay. Put it on there. And now, since we're going to do a liquid, you want to chair it. Notice I'm at 0. Now here, I'm going to fill the graduated cylinder. It's at full. I'll hit this button. And if you notice when I put my cursor over there, it says zoom. Down here, where this gives you the name, that's to pick it up. When it's on top, you'll zoom, click on that, and you'll see this little window, which you can move around. This is a graduated cylinder. Now, I've asked Lab Z in the future, they should change this to 100, not 250. But anyways, this is what we got to work with. If you notice the larger line, that's 230, this one 250. This in between line would be 240. Each one of these divisions is 2 milliliters. So this would be, if you look right here closely, let's assume it's on that line. It's actually a little above, but for now, I also said they should enlarge this window. This is 230, the large line. This line right here, 228. Therefore, this would be a 226. So the volume would be 226. Actually, in real life, it would be about 227. So I'm going to pick it up, pour it in there. And I was right, 227. You divide, here's your weight, and divide it by the volume. That would be about 1, which is what the volume, the density of water is, which you're not going to be doing. Now, when you're done, you can take this over. Little blue handle here and flush it. I love that. That's cute. And now you're ready for the next one. And move this over. You can move this over to things by hitting the green arrows. And if you were, the next one would be alcohol. oops, the virtual fluids are at the end. So if I did it twice, here's our alcohol. You'd have this tiered at 0. You'd fill it up, get the volume, pour it in there, and get the weight. Now, we also have the virtual, which are at the very end. Wrong way. Here's virtual D, C, and B, and A. And I gave you choice of 2 to do. And that's how you do density. And you'll fill the data in here. And that's part of what you'll hand in. Now in part 2, and everybody see part 2 on their screen? Thumbs up, people, thank you. You're going to be doing a solid. Now solids you do by, again, weight and volume, but the volume of a solid is calculated by water displacement. Let's go through this. You'll open the density lab, turn the balance on if it's not, tear it, zero it, then take a solid, and I'll show you this in a second, from the upper right-hand screen, put it on the balance, record the weight in table 2, fill the graduated cylinder with water, record the volume, and this initial one, this first volume, you're going to call the initial volume, and you'll put that in table 2. Next, take the solid from the balance, put it in a graduated cylinder. Next, you'll push the drop button, and now after it drops, you'll record the final volume in table 2. Use the blue level lever to empty it. Now, in the one I have in Blackboard, I forgot to put in the solid part 3 through 9, just says do steps through. I forgot to do that, bad Dr. White, through to each of that, and you'll do each of the solids. Calculate the density. Now here, it's weight, but what's the volume of that solid? It's the final volume minus the initial volume of the water in the graduated cylinder. And here are different ones you'll try. And again, we also have some unknowns. For those of you last name A through L, do solid B. For those M through Z, solid C. Now let's go back to our virtual lab. Now, if you notice up here, and let me ask, everybody see the Beyond Lab Z? Thank you. Oh, we've got super fast thumbs up, people. Thank you. All right, here are your solids. They're in alphabetical order going this way, gold, and then the next one is granite. If you notice, Dr. White found, actually I found an error in their lab bug day right before the semester. They fixed for me and everybody else, so you don't have that. Sodium and silver should be first. But anyways, it goes through the different items. Then at the lower right-hand corner, the last 4 are your virtual solids A, B, C, and D, and you use the one I asked. So how do you do this? First of all, I'm going to take my beaker off there. I don't need it anymore. I'm going to tear the balance, zero it. Let's pick, platinum. I'm going to take it down, put it on there. And notice the weight is this. Put down all the numbers. This is 6 significant figures. It will bounce around a little. Just pick this one would work. In real life, that happens with a balance. Now, over here, we're going to fill this with water. I can find it. There we go. And I'm gonna have it on full. I'm gonna fill it with water. I'm gonna put my cursor where it says zoom. Yeah, down here, you don't want it where it says water. And I'll look over here. A lot of you at first will be over here. You can move this around with your mouse cursor. If I look at this, it's right here below the line. This is 230. Each one of these smaller lines is 2 milliliters. So that would be my 230 minus 2 or 228. So I record that as my initial volume, 228. Now I'll take my ball over here, a platinum, put it in there. Now over here, it says drop, and I'll do that. And it drops. Why did it go to the bottom? Because platinum has a higher density than water, but maybe I'm lying to you. Now you need your final volume. Put your cursor over the graduated cylinder. If you notice, it's gone up. Now, how do we read this? Each line here is 2/10 of a mil, or 2 milliliters, 2, 4, 6, 8. This would be 40. This larger line, not as big here, 240, 242, 244. So this would be 244, or if you notice, it's right on the line, 244.0. For this lab, if you get 3 significant figures from your graduated cylinder measurement, that's good enough. So 244, and you're done. You record the initial volume, the final, the weight. Now flush it, and you're ready for the next one. You'll fill it. Make sure this is tiered. Take whatever it is, put it on the balance, and there you go. And over here are your virtual solids, and that's how you do it. Now, if you want to have some fun on your own, this is not part of the experiment, click on the clipboard. They have some stuff you can play with. Let's do steel and mercury or water. I clicked on that. Notice I have a steel ball, and this graduated cylinder is mercury, which is a dangerous liquid. It's a poison, it's cumulative poison, which is why we don't use thermometers with mercury anymore at home. And here we have water. And now have some fun. Drop. Will it sink or float? I don't know. Let's try it. It floated. Let's do water. It dropped. And why? Because mercury has a higher density than steel, but steel has a higher density than water. And that's how you do it. Now, let me clean this up. And let's do one more. Let's fill it with water. This is not part of the lab. Now, what I'll teach you later on, and maybe next week I'll send out an email of a nice YouTube to watch. Sodium reacts with water violently. So they did that for us. Are you ready? 5, 4, 3, 2, 1, drop. Like I said, sodium reacts with water violently. And when you're done, you can hit the exit sign to get out. Wasn't that fun? Dr. White's organic chemists, when they're young and even when they're old, like to blow things up. We are closet pyromaniacs. I used to burn things with my friends, do experiments in our alley behind my parents' house. And table 2, you'll put in densities, or actually weight, initial volume, final, and calculate the density based on this formula up here. Now, to make things interesting, there's a part 3. Now, DuPage County District Attorney needs to know the identity of the unknown solid liquid, otherwise known as the virtual liquid, and the unknown solid, otherwise known as, AKA, also known as your virtual solid you did above, in order to convict a person of a heinous crime. You must determine the identity of the unknown solid and liquid, or liquid and solid, in tables 1 and 2 by determining the density of the unknown liquid and solid, and thereby helping the DuPage County district attorney convict that person of a heinous crime, I'll let you fill in the blank for what the heinous crime is. How do you do that? The densities in table 4 will help you determine the identity of your unknown liquid and solid in tables 1 and 2. And here, whatever letter designation used above, what was the density you got, and put in the identity. How do you do that? You match it up on this one. And then at the end, there's some questions for you to answer. And again, don't do the stuff in the Lab Z PDF. And with that, I'm done. That's how you do the lab. You'll get to do that on your own at your leisure. I'm not going to say do it right now and have you stick around because you're at home. You can do it tonight, tomorrow, anytime before next Friday when you got to hand it in. Now, what I'm going to do now is in a second or two, I'm going to say goodbye. But if any of you have questions, I'll stick around. If you haven't noticed any videos I post, the questions at the end I cut off because I processed the video, edited it. So with that, I'm going to say, gang gesund, be healthy, stay warm. I'll see you on Monday. Bye. I stole that from Granny, or I'm ambidextrous. Bye. And with that, you can leave. Have a great weekend, and I'll see you on Monday. And if anybody else has questions, I'll stick around.